We need to show that a sine theta plus b cosine theta is given by plus or minus square root of a squared plus b squared minus c squared. And here we're given that a times cosine theta minus b times sine theta equals to c. So let's begin. So what we'll do, we'll consider a sine theta plus b cosine theta. And then we're going to square it. After squaring, we're going to add it to a cosine theta minus b sine theta whole squared. This is then going to give us, so we're going to expand the first term, which will give us a squared sine squared theta plus b squared cosine squared theta plus 2 times ab sine theta times cosine theta. Plus, then we're going to expand the second term, which is going to give us a squared cosine squared theta plus b squared sine squared theta minus 2 times ab sine theta times cosine theta. So 2 times ab sine theta cosine theta, that will get cancelled out. Now we can combine a squared sine squared theta and a squared cosine squared theta by taking a squared as the common factor. So we have a squared multiplied to sine squared theta plus cosine squared theta. Plus, we can combine the remaining terms. So we'll take b squared as the common factor. So that will get multiplied to cosine squared theta plus sine squared theta. So sine squared theta plus cosine squared theta, that's a standard identity with a value equals to 1. So that means we are left with a squared plus b squared. Hence, we can say that whenever we have a sine theta plus b times cosine theta whole squared added to a cos theta minus b sine theta whole squared, then this value is going to be equals to a squared plus b squared. Now, coming to a problem, it's given here that a cosine theta minus b sine theta, that's equals to c. Now that means our second term, the second term a cos theta minus b sine theta can be replaced with c. This is going to give us, so we have a sine theta plus b cosine theta whole squared plus c squared, that will be equals to a squared plus b squared. Now we will transpose c squared to the right hand side. So we have a sine theta plus b cos theta whole squared. So that will be equals to a squared plus b squared minus c squared. So that means we'll take the square root on both sides to get a sine theta plus b cosine theta. This is going to give us plus or minus. Underneath the square root, we're going to have a squared plus b squared minus c squared. This is what we are needed to show, hence proof.